Okay, so with this question, we've got a ship which sails due south from port A for 18 kilometres before reaching port B. It then turns and sails due east for a further 23 kilometres before reaching port C. We've got to construct the diagram and calculate the bearing and distance it must take to return to port A directly from port C. Well, let's draw the diagram first. We have the ship starting at point A, and it says that it's going to sail due south for 18 kilometres. So due south will be down here, and 18 kilometres. Then it's going to reach port B. It's then going to turn and sail due east for a further 23 kilometres before reaching port C. Now we've got to calculate the bearing and distance it must take to return to port A directly from port C. So this is the distance that we need to find, and we need to find the bearing from port C back to port A. Now if we sort of have a look at this is our north here, the bearing, we could get a bit of an estimate of it already. The bearing has to be greater than 270 but less than 360. It's in that quadrant. Okay. So there's a couple of ways of doing working out the distance. Hopefully we can see that this is a right angle here, which will help us. And there's two ways then of finding the distance AC, which is the distance that we need to return. The easiest way is to use Pythagoras' theorem, which is c squared equals a squared plus b squared. From there, obviously your hypotenuse is your x, so x squared is equal to, and it doesn't matter which one you choose for a and b, so I'm going to go 18 squared plus 23 squared, and so x will be the square root of 18 squared plus 23 squared, which when we get out our calculator, we can plug in and get the answer. The other way of doing it is to use trigonometry. So you could be finding that angle there first, theta, which will be required. Let's just finish off this Pythagoras' theorem first. Square root of 18 plus 23 squared is 29.206 kilometres, or approximately 29. Now, does it say where to round to? No, it doesn't, so we just round to a reasonable spot. 29.2 kilometres is fine. We check the reasonableness of that as well. If that's 18 and that's 23, the hypotenuse is the longer side, so that is reasonable. Now, we've got to find that angle in there as well. So we've got to use trigonometry. Let's have a look. With trig and finding an angle, we need to label the sides first with respect to that angle. So that's our angle theta. This side is opposite that, and this side is adjacent to that. So if we've got our SOHCAHTOA written over here, we can hopefully easily see that we've got to use tan, because tan's got O and A. We're after the one that has O and A in it, which is tan. And so that's what we write to find that angle. Tan theta equals opposite over adjacent. So tan theta equals the opposite side, which is 18, over the adjacent side, which is 23. And then to find the angle, you need to get rid of the tan. You need to find theta, so you've got to get tan over the other side. Well, to get tan over the other side, you've got to do the inverse of tan, which is tan inverse. Tan negative 1, 18 over 23, which obviously on your calculator, you need to press Shift tan to work out that. Remembering that it should be set in degrees. D up the top. So that gives us 38.047 degrees, which let's round to 38 degrees. Now we're almost done. Now that's the angle, it is not the bearing though. Remember the bearing, if you look at our diagram, always is measured from north in a clockwise direction. So basically it's going to be 270 degrees to get around to due west, so you've got to add that extra 38 degrees. 38 degrees is that angle in there. 38 degrees goes up in there. So the bearing itself is 270 plus 38 degrees, which is 308 degrees. And so we would say, therefore, the ship must sail on a bearing of 308 degrees for 29.2 kilometres. 29.2 to return to port A. Don't know why that's not working.